question yourself, guys, you come across some question like this one in a test, you have to draw what a free body diagram. So a most important part there, for you to draw a free body diagram, you only consider one object at a time. Something like this there, I can say here object A, and here I can say object B. Do you see? So for you guys to draw for A there, it's straightforward there. We got a weight which is Fg there. Do you see? Which is gravitational force. At the same time, we got what we call a normal force there. And here's another key thing. Here there is applied force. That force there is been applied to on a left hand side. It's been applied on the left hand side. The moment that there is an applied force, it means this thing, obvious, it will move where? On a left there. It will move there on the left there. It will just move on the left. That thing there, it will move there, guys, on the left. So it means on the right there, we got what we call frictional force there. On the right, we got a frictional force. But at the same time, you should understand that there is a what? There is a rope there. And that rope there, it's connected on B. That B, guys, it is pulling A there with a what? With a rope. And the rope, guys, it is what we call a what? Tension force there. A rope there, it is what we call tension force there. This one is a tension force, which is pulling what? It is pulling A by B there, that tension. So that's how you draw what the free body diagram of object A. But for object B, guys, here's a key thing that you should understand. All the time, gravitational force will be there. Gravitational force will be there, which is our weight there. And what you should understand here we don't have a normal force, because a normal force, guys, it only acts between a surface and the object. So here, this thing there, it is hanging, meaning that there is no surface there. It is hanging. There is no surface, meaning that there is no normal force here. But what I say there is a what? There is a rope there. That rope there, it is connected on A, and A there, it's pulling B there with the rope, meaning that we also got what we call a what? A tension there. Here we got a tension there. Do you see? So those are the only force that you have, guys, in this case there. It means that this and that are equal, because they are all the tension, those tension there, they are equal in magnitude but opposite in direction. Do you see? And now, guys, this one is just some vertical surface there, which is this thing there. There is no normal force there. And a vertical surface, there is no normal force. But now let's go to a free fall. Something, guys, which is in a free fall, it's something that it is falling, guys. So this person there, which is object A, it is throwing a ball. That ball there, it will move there in free fall, then it goes down there. Do you see? So for you to draw what for object A, for object B, by the way, object B, and here we got object A there. Then for object B there, what you should understand is that there will only have gravitational force there, which is our weight there. That gravitational force, it is pulling the ball to go down, guys, to come down there to the ground. It is pulling the object to the ground there. That's what we call gravitational force. There is no normal force, and here there is no tension force there. Do you see? Yeah. But now when we go to the object A there, on object A there, we got what we call gravitational force, we got what we call normal force, and at the same time there, this person has applied the force to the what? To this thing there, meaning they also got a what? A force there, which is being applied, which is that thing, it's an applied force there. That person there, it's applying a what? A force to the what? To object B there. Even from object B, that is the only thing that you can draw. But here You can even draw that thing. There's a force which is being applied and a gravitational force there, which is that there's a force which has been applied. But now in this case, now this thing now it is on free fall. It is falling by itself there, meaning now the free body diagram is supposed to be like that there. Do you see? Yeah. So okay, now when we come on this one, guys, how do we deal with inclined surface? This thing you should understand, this is what you call what? Incline angle of inclination. This is what you call angle of inclination there. So in angle of inclination, guys, you should understand now our normal force there will just move like that there, because it's supposed to be perpendicular with the surface, supposed to form 90 degrees with the surface there. Meaning here we'll just say this thing will say it's our surface. That's a normal force there. Do you see? And at the same time, guys, you should also understand that we got what we call a gravitational force there, which is our W. It's pointing downwards there. Do you see? That thing, it's a gravitational force. But that gravitational force, guys, that thing, we can resolve it, that thing there. Here we will have these components which will point on that side. At the same time, they will have the components there which will be here when we resolve this thing. That component there will just take it as units here, meaning that we'll have a perpendicular weight there, perpendicular gravitational force. At the same time, they will have this one there, which this one will call it as a parallel gravitational force. That it's a parallel. This one, it's a what? It's a perpendicular there. This thing there, it will be perpendicular with the what? With the surface, guys. This is our surface. But that one there, it will be this one there, it will be what? Parallel there with the surface there. Let's say this one is our surface. We'll have that weight which is parallel, and we'll have that one there. This one there, it's perpendicular there. It forms 90 degrees with the surface, and the other one there, it's parallel there with the surface. Do you see? So for you now to resolve this thing, it came from here, this thing. It was something like this. It's W normal. So now you should resolve this thing. This will become like this, which is this, and become like that then, which is here, it's perpendicular, and this is what we have there as a normal force there. You see? So here's, guys, the most important part. Remember, when we resolve, guys, we usually use this equation. Do you see? For what? For a vertical component and the what? And the horizontal component. But now, guys, in this case, you should understand that for us to get this thing, our W, it will be represented about W, which is this is sine theta, and this one there, it will just be our W perpendicular, it's W cos theta. But now remember, a W from those equations, which is our weight there, it's mg, meaning this equation there will just be mg sine theta, even as well as that one there, it will be mg cos theta. Do you see? So those, guys, are the new equation that you should know. You will understand when we'll be doing calculations, but so far just take them. So this is what you should know. You should know how to resolve. And now when I come here, and the theta, guys, that I'm referring, it's an angle of inclination there. And m there, it's a mass. G there, it is a what? It is a constant there. That thing, it's a constant. You'll get it at the back of your formula sheet. So now let me just deal with this one.